Welcome everyone. Today we are doing worksheet on similar figures. The theory we have already done, and in this section we will be doing the worksheets. This is the same 21 days GCSE crash course. Before I start, I'll say the same thing. I say the same thing in every video, that I am running GCSE batch classes for all the subjects. So if you want to enroll, I know we have a very less time. So like maybe the batches won't work at this point of time, but you can enroll for the doubt sessions. The doubt sessions are for the specific doubts. You can enroll yourself for it. And for the new session also, whenever the exams are over, you can book a demo. Even you can have a trial now as well. And all you need to do is just email us at exactacademy@gmail.com. I have tutors for all the subjects from year 1 to year 13. You just have to post your query there and we'll coordinate accordingly. Okay, now coming back to the similar figure, here is the sheet, and the first question is areas of two similar triangles are 64 centimeters squared and 81 centimeters squared. If the length of a side of the larger triangle is 15 centimeters, then the length of the corresponding side of the smaller triangle is. If you want to access this free worksheet, it's there on www.exaiacademy.com. And also if you are an Android user, so you can find the app Exai app on Play Store. For this one, definitely they have given that two triangles are similar. If two triangles are similar, that means we know the length scale factor and the area scale factor. So length scale factor is when you divide the corresponding lengths. Area scale factor is when you divide the corresponding areas. They have given two similar triangles. So area first is 64 and another is 81. This is given as, this is area scale factor. And area scale factor is also length scale factor whole square. 64 over 81 is equals to length scale factor whole squared. Taking both root to both the side, it will be now 8 over 9. Obviously, you'll get plus minus, but length scale factor is only positive. That's why I'm taking only positive value. So length scale factor is 8 over 9. From here, I can clearly understand that the length of smaller triangle, because 8 is a smaller value, 9 is a bigger value. So length of a smaller triangle over corresponding length of bigger triangle or larger triangle. This is 8 over 9. Length of a smaller triangle is given as 15, and we have to calculate the length of the corresponding side. Let's say it be x. For length of larger triangle they have given as 15. So for the larger one is 15 and this is x. So x is equals to 8 into 15 over 9. On simplifying, I'll get 3. This is 5. That is 40 over 3 centimeters. This will be the length of the smaller triangle. Moving on to the next question. Here, there is a triangle given PRQ, which is then separated into two different triangles. It says in triangle PQR, that is the bigger triangle, RS is the bisector of angle PRQ. That means this angle is equals to this angle. Now, PS is given as 4 centimeter. This value is 4 centimeters. This value is 16 centimeters. And PR, this one is 24 centimeters. If two triangles are PS, that means this triangle, and RSQ, that means this triangle, they both are similar, then we have to find the value of RQ. That means this. Now the most common thing that will click in your mind, and I would say 98% of the people that they will commit the mistake, is that they will think, okay, that this one, let's say triangle 1 and triangle 2 are similar. So what will be the corresponding sides? PS over SQ. Then it means RP over RQ, and you'll get the answer. But this is not the correct. Why this is not the correct? Because if you are taking the corresponding sides as PS and SQ, so PS of the right hand side and SQ of the left hand side. Similarly, PR So PR of left hand side and RQ of right hand side is equals to, now the remaining is RS. So RS and RS of both are corresponding. It will give you answer as 1 because RS are equal. Whereas this will give you 4 over 16, which is 1 over 4. How is this possible that the ratio of the corresponding side of one corresponding side is 1 by 4 whereas another is 1? So that means the triangles are not similar, but they have mentioned. If they have mentioned, that means the corresponding sides that you are taking are wrong. So in that case, obviously this looks exactly the same. But what if I say this RS is corresponding to SQ? See, let me draw this one here. This is SRP. This is 4 centimeter. This is 24 centimeter. Let's say this be X. And this SRQ, let me think it as like this. I have straightened it up. I have rotated it up 90 degree anti-clockwise. See, if you are moving it counterclockwise 90 degrees, so then what will happen? Q will go up there, R will go here, and S will come here. Now you can say that SQ16 is your corresponding side. Now they are looking exactly the same. If you are taking this one, this one, this one, this one as corresponding, they look like a mirror image. They are not exactly the similar one. Now they are looking like a similar. And RQ and RS is X, because here we have considered RS as X, so this is X. Now this seems to be good. So what will be the, since they are similar triangles, so the ratio of RS over the corresponding side QS is equals to PS over the corresponding side RS is equals to PR over the corresponding side RQ. Value of RS is X, we have assumed. QS is 16. PS is 4. RS is X. PR is 24 and RQ we have to calculate. Now there is no way I can do two ratios like 2 equals to sign. I need to put or to have to find X with the help of two ratios first. I need to take two ratios in consideration first. So I'm taking these two. That is X over 16 is equals to 4 over X. On cross multiplication, it would be X squared is equals to 16 into 4, 64. Taking root, I'll get X is equals to plus minus 8. Again, because it's about the length. So it's going to be 8 centimeters. X is 8 centimeter. Now, if X is 8 centimeter, put the value there. So 8 over 16 is equals to 4 over 8 is equals to 24 over RQ. Now I get to know that the length scale factor is half. So I can take any two ratios here now, taking these two. So 4 over 8 is equals to 24 over RQ. So RQ on cross multiplying, I'll get RQ is equals to 24 into 8 over 4, which will give you 48 centimeters. So RQ is 48 centimeters. That's our final answer. Moving on to the next one. Two figures ABCD and DEGF are two similar figures. If the area of DEGF is 32 centimeters squared, then find the length of AB. Now, this one and this two, they both are similar figures. Now, area of DEFG, only DEFG, area of DEFG given as 32 centimeters squared. So I know that area of DEFG is what? DE times EF, that is length times width is 32. Length we have to calculate and width they have already given as 4 centimeters. So 4 times EF is equals to 32. From here EF is equals to 8. 8 centimeters is now the length, which is equals to basically the length of this one. Now if we have the length of it, we know the corresponding sides. If these two are similar, I can say BC over GF, because the width over the width should be equals to length over the length. So length is AB over length we have calculated as EF. So value of BC is 3, GF is 4, AB we have to calculate, and EF we just calculated as 8. On cross multiplication, this will be 8 times 3 over 4, which is 6 centimeters. So length of AB is 6 centimeters. Moving on to the next question. The height of the smaller cube is 2 centimeters. That means this height is 2 centimeters. If this is a cube, that means the height, length and width, they all are gonna be 2 centimeters. So I can say this will also be 2 centimeters and this will also be 2 centimeters. If the ratio of the total surface area of the bigger cube to the smaller cube is 9, then find the area of the base of the bigger cube. See, either we can directly use dividing the areas, or I can use the area scale factor. In both the ways we'll get the answer. So we know that area scale factor is what? The total surface area of bigger cube. So bigger cube over smaller cube is 9. So this is equals to length scale factor whole square. So length scale factor will be root of 9, that is 3 centimeters. So length scale factor is 3 centimeters. That means length of bigger cube over, if it seems to be a little bit confusing, you can go back and see the video on similar triangles. I have explained the length scale factor, area scale factor and volume scale factor there in detail. And then you can come back to these questions. You'll be able to solve it and understand it very quickly. Length of the bigger cube, length of smaller cube. I have attached the link of the one that in which I have explained the similar triangle theory. This is equals to 3. So length of bigger is, let's say this bx, this bx and this bx. So this is x, smaller is 2, 3. From here I'll get each one as 6 centimeters. So if this is 6 centimeters, this is 6 centimeters, and we know that the base is a square. So area of base is, of bigger one is 6 times 6 is 36 centimeters squared. It's a square, so length times length, that will give you 36 centimeters squared as the area of base. We are talking about this one only. So in base, this is a square of length 6 centimeters. Moving on to the next question. Question 5 says, two right triangular prisms are shown above. Height of the smaller triangular prism is 5 centimeter and width of the bigger prism is 10 centimeters. If the volume of a smaller prism is 500 centimeter cubed and larger is 4000 centimeter cubed, then find the surface area of the smaller prism. These two are two right triangular prism and everything is given here. They haven't mentioned that they are similar, but if such things are given and they look like a replica, so we have to assume in such questions we have to take a consideration that they are similar. And let me see other things. It's at height of a smaller, here it's 5 already, this is 10, we can see. Volume of a smaller prism is 500 centimeter cube and larger is this. So first let me calculate volume scale factor. Let me start from this. Its volume scale factor, well, as I always say that you have to go in reverse order, so we can even start from here as well, and I think that it's better if I start from the volume scale factor. So volume scale factor is volume of larger prism. See, whatever the order you are taking, the same order you have to take. It's not necessary that the bigger should be up there, smaller should be down there. No, you can make any order, putting bigger in numerator, putting bigger in denominator as well. But whatever you have selected for one, the same will go with other. That means if volume scale factor is volume of larger prism over volume of smaller prism, then length scale factor will be length of larger over length of smaller. Area scale factor will be area of larger, area of smaller for that particular question that you have to set. So this will be now volume of smaller prism. Now volume scale factor is larger is 4000 over 500. From here I can say this is 8. So volume scale factor is 8. Now there's another formula for volume scale factor that relates it with the length scale factor. So volume scale factor is length scale factor whole cubed. So 8 is equals to LR whole cubed. From here taking cube root I'll get 2. So length scale factor is 2. Now coming back to this question, what they're asking, you have to find the surface area of the smaller prism. Surface area, for to calculate the surface area of the smaller prism, at least we should know all the sides of it. Length, width, height should be known. Since we get to know that the length scale factor is 2, then I can say that this is twice of it. Simple. Or I can say this be x and this be y, then x over 10 is equals to, or 10. Now length scale factor is length of bigger, which is 10, over length of smaller. This is equals to 2. From here x is equals to 5 centimeters. So I get to know that this is 5 centimeters. Simple, we calculated the length scale factor. And what is length scale factor? Length scale factor is length of bigger triangle over corresponding length of the smaller triangle. Bigger was given as 10 over x is equals to 2 because length scale factor we just calculated as 2. From here you will get x is equals to 5 centimeters. If x is equals to 5 centimeters, now at least we have two dimensions. Now to calculate third dimension, I can use the value of volume given. Because if you see the question, apart from this and this, there's nothing they have mentioned. But they have mentioned the volume of the smaller prism, which is 500 centimeter cubed. And we know that what is the volume of a prism? Area of the face multiplied by the length. That means volume of this small sphere will be area of this face is half times height times base into length. That is 25y over 2 is the volume of this smaller prism. So I'm writing volume of smaller prism is half times base times height times length. And this we have calculated as 500, like this is given in the question. So 25y over 2 is equals to 500 and y is equals to 500 into 2 over 25, which will give you 40 centimeters. So from here I'll get to know that y is 40 centimeters. Coming back to this one, y as 40. Now this one is 40. It's easy now to calculate surface area of this smaller prism because we have to calculate area of the face. This triangular has 5 faces. This one, the front and the parallel, there are 2 faces, the 2 triangles. This is the triangle and this one is the triangle, the front and the rear. These 2 triangles will have the same area. The bottom will be a rectangle, and similarly these two. So let me just show it here and we can calculate surface area. You can see this is the prism here. So we have 5 faces. The front one is a triangle which is half times base times height, and the rear one is the same. So I can multiply directly it with 2 because there are 2 faces of same area, that is the front and the rear triangle, plus the bottom. I'm talking about now the bottom rectangle. This is a rectangle which is length into width, so 40 into 5, plus this one we have to calculate, so length into width. So this length we have to calculate, width is 5, so length we have to calculate. This is hypotenuse of this triangle. So let me say the hypotenuse of this triangle is root 40 squared. This one is root 40 squared plus 5 squared. Answer would be, on solving, we'll get it as 40.3, which is way closer to the 40. So now if only I'm talking about this area of this one, so length times width, that is 40.3 into 5 plus same the behind one, this rear one. So its length is also same 5, and this one is same, that this one is now height. So this will be height, which is 5, multiplied by its width, which is 5. So 5 into 5 will give you 25. So this will be 5 into 5. If we add them all together, the answer will be 6 to 6.5 centimeters squared. Don't use Q. Sometimes I have seen that kids do this kind of mistake. This is 6 to 6.5 centimeters squared. This is the surface area of the smaller prism. Moving on to the question number 6. Two similar isosceles triangles are drawn above the length, like above here. Length of AO is 3 centimeters. This is 3 centimeters given. OD is 12. This is 12 given. And CD is 10 centimeter. This one is 10 centimeters. Then find the area of triangle AOB, that smaller one. To calculate the area, I should know the at least height, length. That means the base I should know, because it's an isosceles. So obviously when I draw a line from the vertex of this will be going to be a perpendicular bisector. So we can easily calculate the height using Pythagoras theorem, but at least we should know AB. I can understand that they have given by this, that they have given that they are similar isosceles triangle. If they are similar, clearly as AOB and COD are similar triangles, then AO ratio OD is equals to AB ratio CD. So AO is 3, OD is 12, AB and CD is 10. On cross multiplying, I'll get 30 over 12, which will give you 5 over 2, 2.5 centimeters. So AB comes out to be 2.45 centimeter, which is 1/4 of it. To calculate the area of the smaller triangle, I should draw a perpendicular. If this whole is 2.5, this is a perpendicular bisector. So this is going to be 1.25 and this is going to be 1.25. And this is isosceles, so this is also going to be 3 centimeters. So by applying Pythagoras, I can find the height. So height would be, let's say this be n. So ON is equals to root of, I just applied Pythagoras, 3 squared minus 1.25 whole squared. Answer will be 2.72. Now it's easy to calculate the area. This triangle it has a height of 2.72. This is height. Base is 2.5. So area is going to be half times base times height. So half times base times height. Final answer is 3.4 centimeters squared. That's the final answer. Moving on to the question number 7. The diagram represents a solid cone. The cone above has a base radius of 5 cm, a slant height of 40 cm. Water is poured up to a height of centimeter. The ratio of the surface area of the bigger cone to the smaller is 9. Then find the volume of the water poured in the cone. So what happened here is, this is the cone given the radius and the slant height we know. Now water is poured up to a height of, they are asking you to calculate of this poured water. Obviously, if you cut them, because the angle is same, the corresponding angles are clearly same. If I make a separation here, because this is same angle and this corresponding angles are equal, as two bases are parallel to each other. So this clearly proves that these two triangles are similar. So CAB and CDE are similar. as they both have same corresponding angles. Same corresponding angles. Now we can move. That means their sides would be in ratio. At least we should know what's the height of this cone, the bigger triangle. So to calculate height of bigger triangle, here this is 40, this is 5, and we have to calculate this height. So on applying Pythagoras theorem, this would become, we have named it as CAB and CDE are the two triangles. Let me name it again. So only I'm talking about this triangle CDE. This C, let's say O, with the center COE. This triangle. So that I have drawn separately here COE. This length is 40. This is 5. On applying Pythagoras theorem, CO will be root of 40 squared minus 5 squared. Answer is, this is 39.68. So we get to know that height is 30.68. Area scale factor is 9. So length scale factor would be root of it. Length scale factor is 3. If you are asking that you have to calculate the volume of water poured. See, if you see this one, volume of water poured, the water is poured till here. That means clearly if I can find the volume of a bigger cone, volume of water poured is volume of bigger cone minus volume of smaller cone. From here we can say that, let me find the volume of the bigger cone. So volume of bigger cone is volume of bigger cone is 1 by 3 pi r squared h. Pi, radius is 5 centimeter squared, height is 39.68. Answer is 1038.8. We know volume scale, length scale factor is 3, then volume scale factor would be 27. So you need to just divide it by 27. I'm writing here volume of bigger over volume of smaller is 3 to the power of 3, because volume scale factor is cube of scale factor, which is 27. So from here volume of smaller will be is equals to 38.47. So finally volume of water poured that we are calculating is volume of the bigger cone that we have calculated as 1038.8 minus 38.47. Finally answer is 1038.8 is 1000 point some, so approximately we can say 1000. We are getting 1000 centimeter cubed is the volume of water poured in this cone. So these were all the questions in the sheet. If you want to access the sheet, in the starting of the video I have told you that just go and log into our website. These worksheets or you can say the study material, they all are free of course. So you just need to go to the www.exacademy.com, and if you are Android user you can just and download the Exi app. And if you want to book demo sessions for the group classes or for one-on-one classes, or even for the doubt sessions from year 1 to year 13 for any subject, even for 11 plus we run the batches one-on-one as well. So just email us at exactacademy@gmail.com and we'll coordinate accordingly. So that's it for today. Thank you. Have a great day.